the LA anchorage starts calculating or starts measuring from the edge of the beam until it bends down. Right, so which means when your main bar touches inside this part, when it goes inside this part, then it will start counting this LA already. So you need to take note of this. Right? Same goes to the bottom bar also. When it goes through the beam, when it starts passing through the beam, then it becomes an anchorage. So let me show you what does that mean. Right, I'm going to create a slab first. And then I'm going to put beams. And now we have beams already. So whenever my main bar touches any of the beam, an anchorage will take place. Right? Let me show you. Go to slab main bar. And then from here, you're going to use top bar. Single, horizontal. We just put one first so I can show you how it looks like. Right, so I'm going to calculate this. So at this point now, I already have a situation that looks like this. Now, you can see that it says net length plus set anchorage plus set anchorage. The set anchorage means that when it touches the beam, that is the anchorage. That's the anchorage value. So when you view in 3D, the anchorage starts calculating when, right? So this is where the beam and the slab intersect. So the LA actually starts from here until it bends down, right? So what is LA? Just now you see inside project settings that it says LA, right? LA means anchorage. When you leave it at LA, when you leave this at LA, it means that it will follow your project settings. The anchorage at your project settings, which is here, slab for first floor. This one, type 2, this one. So let's say if my anchorage is maybe 1000, if I put 1000 here, I close this, and then I recalculate. Then you can see that it goes through like this, 1000. It starts from here until the bottom. So this is how the 1000 is captured. But it doesn't show you that that's how it captured. So it's something that you need to take note of when you key in into your calculation rules at the time. You need to take note of. You can look at the diagram. It shows you that it starts from here, right? Just follow it. So same goes to the bottom bar also. Now, if in the event that you have already drawn your reinforcement like this, but then one side does not have beam. Let's say this side you do not have beam. If you don't have beam, what's going to happen is the bend for both sides is going to be different. Can you see that? One side is 665, the other side is 90. Because left side is applying the LA, but then our right this setting over here. H minus 2 times concrete cover. So this is the situation we need to take note of. The slab is 120. So minus 2 concrete cover, 15 becomes 90. That's why what you saw just now was 90. So this is something that you need to take note of because it affects your calculation a lot, right? So always make sure you know what is what. And then another situation is the edge of the slab. Am I right? You will also have conditions where your slab is at the center. means you will have one beam in between your slab like this. And let me show you what happens if I adjust my slab. If I drag my slab until the edge here, for example, let's say this one also same thing. I pull over to the edge a bit so you can see what the anchor look like. You see, when I draw my main bar, it doesn't go all the way inside the beam. When I calculate it, it still goes all the way in. Can you see? I draw the line until here, but the reinforcement goes all the way in here. So it's like half of the beam width. So if you look into the calculation rules, you can see that it says 0.5 times HA, which is half of the beam support or half of the wall support. So this is how the software actually reads the information, right? We need to be able to understand and identify why does the software do that. So first, when you want to adjust any reinforcement, make sure you check the main bar reinforcement and the bending over here, because I'm pretty sure you need to change the information over here. Well, if you don't want to change the information inside here, you have a specific length, you can just straight away change it over here, left and right bend. Right, you can change the information directly from here. You can put like 120 on the left, 120 on the right, depends on how you want to see the bend. So there are two ways for you to adjust that. One is by using calculation rules. The other way is by using 120, 120. So up to this stage, you guys understand how the concept is? You guys understand the situation? How does it actually bend down? Kun Xiong can understand. What about others? You guys understand how this concept is? Whenever it touches a beam, right? If it doesn't touch the beam, then there's a situation. That's why there are certain errors that people will usually face. Very common errors they face is this. Okay, let's say the type of common error that people will usually face is when they draw a slab, they draw the slab first, then only they draw the beam. So when they draw the beam, what happens is this. Here they draw correct. And then there are certain times where you accidentally draw until the edge like this. Right, you can see that there is a small gap over here, but when you zoom out, you can't see the gap. So there are situations that people draw like this. See, you got gap over there. So when you draw like that, and then you put the slab reinforcement, you will face this problem where it doesn't follow the settings. It's actually quite common that people face this error. then it becomes 90-90. It does not follow the setting already because it's detected as a cantilever. So we have to be very careful when we are dealing with this situation. Try not to use manual drawing on your slab. Use point. Rely on the beams as your mold instead of manually drawing all the slabs out, right? Because we want to prevent this type of situation. It's not that the software cannot do it for you. Just that if we do it, we have other concerns also. You will tend to feel like it's inconsistent. So that's why we want to make it in such a way that it's inconsistent. We want to make it in such a way that it has to be exact, so that the error is easily, you can easily tell the error. You can easily check, right? So in cases like this, always make sure you check first before you put in your reinforcement. You zoom out, you cannot see what it looks like very normal until you zoom in, and then you can see that there is a small opening over here, right? Okay, just be careful. Now, there is another very common question that people will usually ask. Can slab support bar be adjusted inside calculation rules? In fact, yes. You can actually adjust your calculation rules for slab support bar. Now, a lot of people don't know what's the difference between a slab support bar. So let me show you the difference between a slab support bar. When to use main bar. When you are dealing with slab, what I usually do is, let me delete everything first. How to know when is the time to use a slab support bar or slab main bar? Let me show you. Okay, first thing first, if I look at this type of drawing, to me, how I tell which one is a support bar is by looking at the drawing first. So over here, I know which one is a slab support bar, right? I know this one is a slab support bar. This one is a slab main bar. And then this one at the side here is a slab support bar. Now, let me tell you why I say this. Because when you go into your drawing, if you are using slab main bar, it covers the entire slab one. For example, like single, X and Y, it covers the entire slab. So I'm just going to put like this. So it covers the entire slab. But when you are using slab support bar, it actually covers part where there is, what do you call that? There is another kind of anchorage between the slab and another element. For example, like this beam, right? There are certain situations or certain drawings you receive that they want you to draw your reinforcement like this. But of course, it's straight one, not like mine crooked one. But there are certain situations, certain drawings that requires you to draw the top bar like this, right? So I'm not going to use main bar to draw this. You can use main bar to draw also. I would recommend you to do this because it's very troublesome. So what I would recommend you to do is use slab support bar and then use arrange by beam. So I click arrange by beam. I just need to point onto the beam. And then here, I can key in the length information, left and right. How to key in the length information? 1/3 times the length of the slab, the width of the slab, right? So that's the situation. We need to understand this, right? This is when we use slab support bar, always at the side here, right? So of course, it does not mean that if I put like that, left side also will have bar lah. You can straight away put 0 here. This one also same thing, you can put 0. Right, so this is how you do your slab support bar. Slab support bar again sits on beams, sits on walls, and so on and so forth. Right, just to let you all know how it actually works. Now, here, what I want to say is sometimes you get a type of measurement that looks like this. It will tell you, oops. It will tell you to use 45 mm diameter or half times, wait, let me see what is B. B is beam width, okay. 45 mm diameter or half times the beam's width. So this is what it will tell me sometimes, right? So when I go into calculation rules, I can look for my slab support bar. Okay, when I look at my slab support bar, you can choose whether you want to have your measurement starts from measuring from the inner edge of support, which is from this part here, this point here. Inner edge of support means inside here, or you want to use support axis line, support center line, outer edge of support. Then this one I think I show you later inside the slides. I think I have it inside the slides. Yeah, later I'll show you inside the slides. So when you want to adjust the information inside your support bar, what I usually do is, let me check. What is my beam's HA support width? Okay. So what I usually do is, just now it says that I need to have how much? 45 diameter or half times support width. So what I need to do is key in like this. Maximum 45 times diameter, comma, half times HA. Let me see. Sorry, it's HC. So this is the situation, right? So I want it to be like that. So then you can just calculate, and then the software will automatically capture whichever that is bigger. Right, so I think this one is actually 45 diameter lah. Set Anchorage. Like, let me see. Diameter is 12 mm. So (45 times diameter). That's 540, as you can see, which means your 540 is way bigger than half time my beam width, right? So you can key like this. This means my software will either take 45 times diameter or half times your beam width, whichever is bigger, right? If you change the max word to minimum, then it will mean different already. You will take whichever that is smaller. So let's see what happens if I change to minimum. You can see that it takes half of the beam's width. 175 is half of the beam width, which is 350, correct? Okay. Now you know how to adjust this, whichever that's greater. It does not apply just to your slab support bar. This function, you can do it like max 0.15 times L plus half times HC or whichever. You know, you can actually use on any kind of reinforcement inside inside TRB one. For example, your beam also you can use this formula, right? Max, minimum, comma, right? So these are the things that you can use. Oh, actually it's not 45D or 1/2B. It's actually 45D plus 1/2B against 0.15 L. You can see over here this maximum. Let me see whether I can copy that. That's the information it's supposed to key in. Okay, I can copy. So you're supposed to put this instead. My mistake. One over 2 times HA, okay. Did I put anything wrong? me copy again. So you can see that the software will take whichever that is longer or bigger, right? So you can actually try to play around with this figure next time, right? You can refer to the slides, how we actually do it, which is just to key in max 0.15 times L plus half times HC, comma 45 times D plus half times HC again. So remember, it's not just for slab support bar, you can do it for beam also, right? Any questions for this part? So far? So far, so good? Everyone able to follow up to this stage? Know what's the difference between slab support bar and calculation what do you call it? Slab main bar? Okay, Phoebe says yes. Kunxiao says yes. Yeah, because a lot of people ask me why I have to use slab main bar and not slab support bar, this and that. You can use either one also. It's just that whichever that's convenient to you and whichever is easier for you to label. So that's the thing. Right. If there is no questions for this part, I shall move on to the next item, which is trimmer bar. So I also received a lot of questions from people asking how to set trimmer bar. A lot of people don't know that trimmer bar actually has a calculation rules inside. So trimmer bar actually works like this. If I have an opening from a slab, the slab inside here, you can key in the trimmer bar, right? You have shorter, longer, right? So forever, let's say I take the shorter one, which is, I make one shorter, one longer, easier. So the length will be the longer one. So say for example, I'm going to put 4T12. And then for the shorter one, I'm going to take 4T10. Right, so I already key in already, calculate everything, and then it gives me the information, it gives me the reinforcement information over here. But the thing is, how do I know what is what? Because I don't know what is the information that I'm supposed to do with this. You see, you can see that there is data over here, but how to change the information, for example, the trimmer bar length and things like that. So you can actually change those trimmer bar info by going into the calculation rules. Under slab again, head to slab opening, then you can find this one, B plus 2 times LA, B plus 2 times LA. If you want to have a specific length, then you can just put it like 5,000, for example. Yeah, 5,000. Right, so when you close this, automatically both will become 5,000. You see that? The cutting length. So the length can be changed inside calculation rules. Right, and if you have an oblique length, you can key it inside here also. So this is the thing. I think trimmer bar should be quite easy, nothing much to show for this also. If you have questions, feel free to ask me inside the chat. Otherwise, I'll just move on because this one is a bit simple, just to show you that you can actually adjust the trimmer bar over there, right? Now, cantilever slab. This is the one that I mentioned earlier on just now. The differences between a cantilever slab and a normal slab, which connects straight into a beam or a wall, right? So you can see over here, if you are facing, let's say your reinforcement is facing outwards to this part where there is no beam, then it's categorized as cantilever. But if it is facing up to beam this location, then it is considered supported, and then you have to use this calculation method over here. Right, so make sure you know which information is for which information. Don't just change, and after that you cannot get them correctly. Right, always try to understand what you have inside calculation rules before you do anything. If you don't understand, then you'll face an issue trying to get everything correctly. Okay. So this one also quite straightforward, not too hard. I think I showed you already just now. That's why I think you should most likely understand the information here. Now, the support bar just now that I wanted to show you, there are a few types of measurement for support bar. First one is if you want to start your support bar measurement from the inner edge of the support, right? Inner edge of the support means it starts from this point here, right? It starts from this point here. Or if you want your slab support bar to start from axis, which means it starts directly from the center point over here, following the axis of your of the created axis grid line that you have, or support center line, which is also same like axis, but because the axis is just so happen at the center of the support, so it follows the axis. But if you are using support center line, then it follows exactly directly from your support center line, which is your beam or wall, whichever. Or the outer edge of support, which is at the outside point here, right? Start from outside here. Very unlikely for us to choose that one. Length of support bar line, right? Or the exact length that you key in inside here without the anchorage LA. Exact length is without the anchorage LA. So it depends on which one you feel like using. But usually we don't change this. We always put as inner edge of support plus the anchorage LA. If you don't want the anchorage LA, then you just put length of support bar line. So you can change this information inside here, inner edge of support. Then next one is the support bend, bending length of support bar cross or cross main bar, cross slab main bar, right? So the bending length is actually the support bar length. So you want to set a default settings also can, but if you don't want to set also can. The software will automatically have a default settings, which is H, the height of the support or the beam, minus 2 times concrete cover. Right, minus 2 times concrete cover. You can change this information if you want to, right? So this one is for a support bar bend if you want to adjust it automatically. How about the bending length of support bar or cross main bar? The span, the calculation method for the span length, right? We have a few types. One is span parallel to the current bar, right? Which is what we want to use. We don't want to change that, which means that this is my reinforcement. This is my reinforcement. What is parallel to this reinforcement is of course this slab line over here. So it will follow this slab line, right? Or if you want to choose to use longer or shorter span, longer span is of course this one, no? Shorter span is the shorter one, no? If the shorter span here is longer, then it will be categorized as longer span, no? And then this one will become shorter span, no? Depends on the situation, right? So in cases for this item, we usually don't change anything. Span parallel to current bar is correct already. Unless otherwise your engineer states that you need to use the longer or shorter span, whichever, right? For support bar, everybody okay? Able to follow so far? I think support bar should be quite straightforward. Most of the things you can change inside there, but I don't recommend you to change. Okay, so now we move into distribution bar. So distribution bar and calculation rules. Have you actually used distribution bar before for the slab support bar? It only occurs into slab support bar. For slab main bar, you don't have distribution bar. Have you all used this function before? Distribution bar? Yes. Okay, good. So if you have used this distribution bar, I'm pretty sure you're quite curious how the distribution bar is measured by default, right? So by default, the software measures by calculating the lap length with support bar, which means that if in the event that if this is the support bar that you are drawing, right, this one is the one that you're drawing, if you have some existing support bar over here, your distribution bar will stop until the support bar here. It will stop at this point, right? It will stop at this point and then lap at this location. So this is the default settings, right? That's how the distribution bar is measured. But if you don't want it to be lapping with the support bar perpendicular to it, then you can use follow axis length or range fade length, which I don't recommend. I don't recommend either one of these, because if you do follow axis length, the quantity is going to be a lot. Follow the range slate length, quantity is also going to be a lot. There will not be any deduction for overlapping areas with your slab support bar. Right, so that's the condition or the situation that we are currently facing right now. Okay, then, next. Variable slab drop. This one is actually quite interesting. This is a question that people ask a lot. So when we talk about variable slab drop, how many of you are actually familiar, or you know how to change the settings over here? Are you guys familiar with these settings? Drop variation. Have you guys ever used or changed anything inside this variable section before? Yes, okay, good. Others never used before? No. Okay, no. All right. So variable section is a very important part of your slab, right? Because your slab is not just straight all the way one. There's definitely going to be drops over there. Now, how to tell what is what? You can see that there are two types over here. We have variable section for one part. You can see the reinforcement that it actually goes all the way straight through. You can see that it goes straight through like this. You can also see that there are reinforcements that go through, but then there is a bend in between like that. Right? So these are two things that you will see. Now, when you go into the software, let me show you different conditions. Okay, I want to remove everything again. Too many things, not very difficult to see. You draw a slab. Maybe make it thicker so it's easier to see. 100 mm, and then you have 350 mm, and then you have 300 mm. Split. S4. S5. Okay. Now we have a few different kind of size. We want to look at how the drop works first. So I'm going to adjust the drop one by one. This one I'm going to adjust the drop by 50 mm. This one I'm going to adjust the drop by 100 mm. Oops. Okay, now I'm going to put some reinforcement over there. We're going to put one top and one bottom. Okay, we put one top and one bottom. Okay, now let's look at the first setting first. The first one is my slab here drops by 50 mm, right? 50 mm with the calculation rules. And then we go and look at the drop part. Okay, now it says variable section. If my drop is less than 50 mm, then I will actually take this amount, right? If it is less than 50 mm, it will actually drop. I mean, the reinforcement bar will actually directly connect, so you can't see the bending part like this part over here. But if the drop is more than the set value, if it's more than the set value, then it will definitely break, cut and break after that, anchor like this. Right? So let me show you. This slab has to be less than. The drop has to be less. Let's say 4, 6. Okay, then we calculate. You can see that it does not anchor, right? It does not anchor. It does not anchor in like this part down here. Right, you can see the differences between two. This one is more than 50 mm, but the one on the left is less than 50 mm. It's 40 mm drops only. So when it's 40 mm drops, it will not apply this part of the reinforcement. It will stop here, and after that it will connect with another reinforcement, which is this one. So this is how the software actually reads this information. So you must be able to tell what is what, because if you don't know, then it's very difficult for you to do all these settings, right? So once you already identify, if you really understand how does this work, this slab drop things works already, now I want to adjust the length. I want to adjust the information over here, for example, like this one, right? I can scroll down and then I look for section change. This one is for bottom. This one is for top. Right, just now we were looking at top. So instead of LA, maybe I make it to something more simple like 500 mm. 500 mm. And then just close and recalculate again. And after that, you can view in 3D or in Edit Riba. You can see that it becomes 500 mm already. So that's the thing. You can read inside the information over here. You can actually change it also if you don't want it. You can like change it like this. 500 mm, 500 mm. Close it. Right? They can see this 500 mm over here. So up to this stage, is everybody clear? Is everybody clear with how the variable slab drop section works? Yes, very easy, right? So once you get to know how does this slab drop works already, next time when you want to adjust for your scupper drain, or you want to adjust for your any slab that has dropped that has this kind of reinforcement, then you don't have to worry already. Because this also actually applies on situation when you have thickening, right? So a lot of people, they don't understand they are worried that what will happen if I have thickening. For example, like here, let me draw one thickening and show you. Okay, maybe I draw a slab here. Same thing, I'm going to draw two different pieces of slab. Now I have two different pieces of slab over here. So a lot of people, sometimes they find it difficult to understand what happens if I have a thickening in the center over here. 0. Okay. Right. What happens to my bottom reinforcement bar when I have a thickening that looks like this? The software will bend for you one, so you don't have to worry. Right. So now what I do is I'm going to put a bottom bar. To both of these slab. When I calculate it, you can see that it actually applies just now the setting that we saw, which is inside calculation rules. You just need to scroll down. It applies this setting. Right? So you don't have to worry whether there is slope or not. If there is slope, the software will actually do the measurement for you as long as you key in all your information inside calculation rules correctly. Right? So this is for variable slab drop section. You're finished for chapter 5, chapter 4. Any questions for chapter 4? You have any questions for chapter 4? Okay, I'm seeing that there's no questions. Everybody looks okay so far. Now, slab is very easy only, nothing much for you all to do. So now the next one is we have chapter 5, which is foundation. Foundation is a very there is a lot of things inside foundation, but it's actually not hard to use at all. It's much more simple compared to other elements, right? So why I say it's simple, let me show you. Sorry, choked my saliva. sorry. Okay. First item I talk about is outcap. Now, a lot of people, they think, okay, if I'm dealing with foundation, pad foundation, power caps, like all those any other elements, for example, like similar to power cap one will be tossed under power cap. That is okay. I do that also, but I still have to bring you through other elements as well, the differences between power cap and those elements. And if you ask me personally, I also like to use power cap. Everything I throw under power cap, for example, like my pad foundation, it's supposed to be a pad foundation, but I put it under power cap also because I like to use power cap. The functions, they are much more visually and easier to use, I would say. Right? So power cap very easy. Inside calculation rules for power cap, we only have two things: the band and the number of rounding method. So you can see that there is a band over here. This one is generally to your top and bottom bar. And also bending length of additional bar. If you have put in inside your additional bar, then the bending will actually follow these settings over here. Because there are many situations where your additional bar is actually different compared to your main top and main bottom bar. So we allow you to do the changes here inside. And then the next one is number rounding method. This one I think I don't need to explain. It's quite straightforward. You should be able to tell what's the purpose of this number rounding method, right? Then we go to the next item. I think power cap, there's nothing much, it's just that. Let's go to the next item, which is rough foundation. Now, when we talk about rough foundation, here we have a few types of rough foundation connection. It's same like slab. I would say that it's 90% the same like slab, just that it has additional few more functions and maybe the visual is slightly different. For example, like just now that one, instead of slab to beams or slab to RC wall, now it's actually rough to ground beam and rough to your RC wall, right? So it looks different, but it's actually the same settings, right? So don't be confused. So same thing, if you have a support at the rough foundation there, then this is the setting that is going to happen, right? Or the Anchorage setting that's going to take place. Same like your reinforcement that I've taught you just now for slab, right? Even the wall also same thing, right? The measurement method is the same. But something else different here is because instead of using cantilever slab, we don't have cantilever slab now. Ground beam, the one is not called cantilever slab, it's just a suspended slab that has no support towards the edge. Because the rough foundation itself is the support. So that's the situation. So in the event that that happens, same like just now the cantilever slab, you will have a separate calculation here that you need to change for the bending, which is this one over here. And this one. Right? Very straightforward. So apart from that rough foundation, we also have a different calculating method for sidebar. If you notice, big rough foundation or big hull cap, usually when there is a hull cap, I will use rough foundation to draw it up because it's easier to draw the shape and it's easier for me to adjust the reinforcement accordingly. So in the event that you are facing those issues, what I will do is, if you have sidebars that are actually lapping against each other, I can use by lap standard value or by lap specified number, right? Specified number means you put the number of lap inside there, then you choose how many laps do you have in this particular hull cap or this particular rough foundation. So that's the thing that we do, right? Then after that, you can also input the anchorage length. You can input the anchorage length inside so that the software knows that, okay, when it comes to this type of turning point, the sidebar is going to fold in, and then after that, it's going to anchor itself inside the other side of the what do you call it, the rough foundation, right? So you can choose this, or you want to put 0 also can. It's up to you, whichever that you feel comfortable, right? And after that, the last one we have by links. By links is actually, I would say that it's similar to labs also, except that instead of it uses lab, it is actually using hook. It's actually using hooks. So that's the thing. So let me show you how you can actually deal with this situation. Let's go into TRB. Now, assuming the rough foundation, under rough foundation, I shall create this item over here. Okay, let's say I create this rough foundation, right? Where I have side main bar. I put 4010, for example. So when I calculate the time, you have side main bar over there. See, this is the one that you saw just now, 4010. Then after that, by default, it's actually using this. So when I go to calculation rules, under foundation, and then scroll down a bit, change the method of calculating sidebar value. Instead of using my lab, I choose, let's say, my link. And then if you have lab value, then you just put your lab value. Otherwise, you just leave it be, press OK. And then the software will change. It will become a link. Can you see that? After that, you add a 24 mm diameter and 24 times diameter. Is everyone okay for rough foundation so far? Actually, very straightforward and easy. So nothing much. Towards the back here, also the same thing. Change this one. Same thing, if you have the lab one, like I mentioned just now, the lab, just press this one. And then you can just put in the number of, labs that you have. If you have 10 labs inside this particular sidebar here, then you just put 10 labs. It's totally up to you. How many labs you want to put, right? The lab length, then you have the anchorage length, and then if the corner there, all your bending length looks like this, then you can insert your bend length as well, right? So up to this stage, anyone got questions about rough foundation for this part? I think it should be no, right? If no, then I continue the next part of the rough foundation. Now, this one is similar to just now the slab support bar, rough support bar, right? You can choose whether you want the span to be parallel to the current bar or longer or shorter span. But of course, we leave it to be parallel to the current bar unless otherwise stated by your general notes to use following either the longer or shorter span, right? So always make sure you check the general notes first before deciding to use anything. Very important. This one is another one that I want to explain to you. Now, this is another thing that is actually different from your slab reinforcement, which is whenever there is a beam passing by your rough foundation, by default, there will not be any horizontal bar that is passing through your ground beam one. If this is your ground beam, this one is your ground beam, right? Inside the ground beam, you won't have horizontal bar one. You will only have reinforcement that anchors into the beam so that it doesn't move around. So that is for ground beam. Same goes to the bottom one here for support bar, right? If you're dealing with support bar, by default, your support bar, when intersecting with your ground beam, it will not have, okay, let's say this one is the support bar, right? This one is the support bar. You can see over here. You draw the support bar already. Inside the ground beam will not have this support bar. This is the setting, right? Well, if you want it to be inside, then you just choose this one. You can just choose yes, switch to yes instead. And then the last one, arrange main bar at the intersection with ground beam, rough or slab strip. Okay, for this one is, you can choose whether you want to arrange the main bar when it meets with the ground beam or not. Like for example, this part over here. Do you want it to be inside there or not? Like manually arrange inside and then after that make sure that there is two reinforcement inside ground beam. But usually you put no, we don't want, because this information will be placed inside your what you call that, ground beam. You will be labeled under ground beam instead of your slab or your rough foundation. Right? So make sure you know what you want first. Okay, this one is rough foundation, the rough variable section. Similar to what I showed you just now inside slab. This one is actually exactly the same. So I find it pointless for me to re-explain this part. But just to let you know, this one is exactly the same as slab that I've explained earlier on just now. So the concept is also the same, exactly the same. Rough foundation, any questions so far? That's the end of rough foundation already. Anyone finding any difficulties in doing rough foundation? Okay. Is the calculation BRC slab main bar and the rough foundation similar? It's exactly the same. It's not similar. The rough foundation BRC is exactly the same. So if you have any BRC things related to calculation rules inside rough foundation one, is the same. You can refer back to slab also. Because basically there's nothing much for BRC. If you go inside BRC calculation rules, all you would do is you can see this part only. It's the same one here. Also the lapping. Same thing. Okay? All right. Any other questions so far? No? Okay. If no question, then we go on to the next one. Some pit. Now, Hold on. I forgot to convert this into PDF. Let me send this over to you all first. Send this to you all first. Okay, it's uploading. Later, you just open up this one. We have some sample inside here where you can refer to how to actually adjust all this information. Okay, sum-pit. Honestly speaking, sum-pit is a function that we rarely use. People rarely use, but I still need to show you a bit. In the event that you need to use this function next time, you can just use without asking us how to use this function, right? So sum-pit is a very special element. It's part under foundation as well. So when you go into sum-pit, there are certain things that you may need to understand first. This is basically not really calculation, but if you talk about sum-pit, you can see over here at the bottom, when you click into a sum-pit, it will show you what to do with the sum-pit. For example, like this one, it label for you horizontal bar, sloping bar, slab top elevation, slab thickness, slab bottom width extension, X direction bar. So you got all these kind of things inside here. Right? Choose that. You can choose all this information inside there. But the thing is, when you are dealing with this type of situation, question is that what's the purpose of using this sum-pit? Do you really need to use it? Like, under normal circumstances, I usually just manually draw my own opening and after that form the sum-pit out. I don't really use this because the design here is a bit fixed. So a lot of things when I want to customize is a bit hard. Not to say that you can't use. You can use. This function is useful when you have a lot of exact same sum-pit, right? When it is different, then there's no point using it. But when all your sum-pit is the same or typical, then you can use this function, right? So how to use a sum-pit? First thing first, you need to have a rough foundation. For example, like this rough foundation. Yeah, I'm just going to put a sum-pit here. So I'm going to draw a rectangle. This is too big. Let me draw a bigger rough foundation. Okay, when I point your sum-pit over here, automatically this sum-pit will have reinforcement one. So if you don't know what is what, you don't know how to label, very easy. You just open this one, enlarge it, so that you can read the information over here. Now, X direction bar. What is X direction bar? You can see it says over here, this is X direction bar. The one bar at the bottom over here, right? That's sloping up one. So let's just assume that this one is T10 at 150. Y direction bar, same thing also, just that it's the other way around, right? It becomes the Y direction of this dot over here, the pink dot that you can see over here. Pink or purple, I don't know, either one color, right? So this I'm going to put T12. Then after that, side horizontal bar. Where to find my side horizontal bar? You can find it over here. Horizontal bar at the side. So I'm going to put again 14. Then after that, your slope rebound. Also another time, 20. For example. So once I've done that already, close this, calculate, you'll get a reinforcement over there. So this is how the reinforcement looks like. Then you need to check your drawing again to see whether this is the exact shape of your reinforcement that you want it to be or not, right? Okay, let's take a 10 minutes break. We continue at 3:20. Take a 10 minutes break. And at the same time, you can just click open these calculation rules and have a look at those items inside here first. Right, so basically here I already show you how to join this information over here, right? So you can try to fill up, like for example, this offset 50 mm, the lap length is 40 mm, right? All this information, you can try to fill this up. Here I already show you where you can find this information. You can adjust inside here. Same goes to your wall, reinforced wall settings also. You can find all the adjustment inside here, right? Then we have stiffener also. No, have most of you, have you all actually used stiffener, that function? I think intermediate training, we taught that. Stiffener, you can actually auto lay on everything. It's quite useful though. You don't need to manually point everything one by one. Just have a look at this first. This is something easy to refresh a bit things that you have learned earlier on. Okay, we take a break now. See you guys in 10 minutes. 3:20. from a toilet break. Everyone's back, right? Hello, anybody there? Okay. All right, we got 2% that's back. Okay, I'm just gonna assume everyone's back until if you say you're not back. Okay, right, so let's continue. Now, so this is for some pit. Some pit I'm not going to talk too much about it because it's a rarely used item, but I just need to give your insight of how the some pit looks like. Right, the calculation rule is also very simple. When you click inside project settings, you go to calculation rules. It tells you about the band only, right? The band at the bottom over here. And then at the same time also, if you have any particular band at the corner side, right? The horizontal corner sloping side there, then you can adjust the bending length over here as well. So other than that, that's just about it for some pit. Nothing too special that we need to bring up about. So let's move on to the next item. Pad foundation. So remember just now I talked about pile caps. This is the item that I'm mentioning about. So usually when it comes to pad foundation, I would usually use back pile cap to draw because pile cap is much easier and there is more functions inside pile cap which I can use, especially when it comes to customizing your pad foundation or your real pile caps. So depends on the situation, depends on your preference also. If you like to use pad foundation, then just go ahead. If you want to use pile cap, also can, just go ahead. Nothing wrong with that. Okay, so the only differences between pad foundation and pile cap is that inside pad foundation you have this item Anchorage in cup shaped column, right? Which is something that we rarely use also. So that's why I don't want to talk too much about this pad foundation, right? Or the arrangement of the reinforcement bar between the intersection of ground beam and the pad foundation, right? Whether you want to have a rebar that passes through or not when there is a pad foundation, when there's a ground beam that passes through your pad foundation. So cases like this, we want it to pass through because pad foundation is more important than the ground beams. So whatever reinforcement inside there should not be omitted because of the ground beam, right? So usually we leave it at yes. We don't change it unless otherwise we need to. So for pad foundation, we're not going to talk much about it. Very simple. Strip foundation. Now, strip foundation is something that people use, but not many. But I recommend you all to use. Why I say so is because when you are dealing with, okay, have you guys heard of wall bases? Or what you want to call it? When your RC wall actually, or your Eco-type wall actually sits on the base. It's similar to a pad foundation like that, but it is all along your wall bases. RC wall base. Have you guys heard of that before? Maybe let me show you a project that I have done from before last time. It's a real project, legit one. I think this one. Not sure whether it's this one, but let me check first. Let me see whether this one has wall bases or not. Okay, something that looks like this. Your wall is actually sitting on something that is protruding out. This is one of the type of wall bases that you see over here. It's actually sitting on a thickening that is actually protruding out. So this is one of the method, one of the wall bases that you see here. Or maybe there's another project that I can share with you. Maybe the more obvious one. Let me see. Okay, this one is also the one with the wall base. Okay, this type of wall base. Have you guys encountered this type of project where you need to go through this type of wall bases before? Like it protrudes out and sit on the the RC was actually sitting on the wall bases. That this is the strip foundation that we are talking about. No, yes. Okay, I'm going to take it as a no, never seen before. All right, never mind. So let me show you how to use a strip foundation. So when we talk about strip foundation, you can actually create this strip foundation, then you adjust. It's similar to your pile cap, just that this one is linear type, right? It's not point type. Pile cap is considered point, but for strip foundation, it's linear. You can just draw along your wall. So let me show you. For example, go to foundation, and then we have strip foundation. Create a very basic strip foundation. So this will be my strip foundation. Oops. My unit, rectangular unit. So this one is a strip foundation. It's linear in shape, right? So usually your wall will be sitting on your strip foundation. Okay, so this is the situation. This is the type of strip foundation that we are dealing with, right? So inside strip foundation over here, what you can do is you can insert the main bar, distribution bar, and then if you have other rebars you want to put in also can. And you just need to calculate it. And you can view the reinforcements. And it should look something just like this. So this is your strip foundation. And then if you don't want to have this distribution bar, you can actually remove it. You can remove your distribution bar by deleting this one. And you might only need the main bar. Right, depends on the situation, depends on how you want the strip foundation to be. So you can go inside project settings, calculation rules, and look for strip foundation as well, which is at the bottom here. And then you can adjust the information over here, H minus 2 times BHC, then whether the distribution bar is parallel with the intersection of the ground beam or not. You can put yes also if you want to. Then after that, you can close it. And then just recalculate it. Put in my distribution bar first. And this is just about it. This is how you actually create your distribution bar. Very easy. I think this is not difficult. Strip foundation, you can call it wall bases also if you want to call it. Last time we used to call it wall bases in my BQ. But now I don't know what's the exact name for it. You can call it strip foundation, right? So that's all only for calculation rules to your strip foundation. Nothing too special also, nothing too difficult. Then we go into strip foundation. Well, this one is the same thing. Yeah, this one is the same thing. So you can choose also if you have multiple distribution bar passing by. If you have 2 distribution bar, for example, like if you have a situation where, let me remove this wall first. The wall at this point is not relevant because I want to show you strip foundation. So you may sometimes meet a strip foundation like meeting against each other like that. Right, so what the setting tells you is this. So there are certain situations when you meet your strip foundation, you can choose whether you want them to continuously pass at L join, or you don't want it to continuously pass, which means once it reaches the L point here, it will actually stop and then you don't have the distribution bar going through. So this is the question, whether you want or not. So we don't want to short count any quantity, and based on your drawing, if the drawing says that the strip foundation goes all the way inside, distribution bar goes all the way inside, then I'm going to leave it at no. Or if your engineer tells you no, we don't need the distribution bar at the connecting point, then you can just change it to yes. Depends on the situation, right? Or you may have a situation that you have 2 different strip foundation, a main strip foundation and a secondary strip foundation. So what this does is that when the main strip foundation meets with a secondary strip foundation, it will actually just lap this part over here, right? It will lap this part. Excuse me. It will go all the way. It will penetrate through your main strip foundation and then only up to this part, which is 150 mm that I keyed just now, right? So let me show you if I change it to secondary. Calculate these two. And then you can see that this actually goes in by a bit, 150 mm. It penetrates in 150 mm. So this is how the software reads the strip foundation when there is a main and there is a secondary strip foundation. Depends on your general notes. Again, up to this part, strip foundation, everybody okay? Is everyone okay with strip foundation? Okay. Others? Okay, good. All right. Good to hear. Now we move into this one is just now the question that you asked me, steel fabric or PRC to rough foundation. Is it the same? It is exactly the same. Just to let you know the differences between these two items, like calculating fabric area and calculating area from weight. So just to give you a hint of what this actually means, when you are calculating fabric area, whatever you draw, which means whatever you can see on the plan is the exact area that you'll be capturing inside the software, right? But this area will also include the band downwards. For example, if there is a band inside the rough foundation, then the band will also be considered part of the area, the fabric area. So that this is called calculating fabric area. And then we have, by calculating area from weight, what does weight actually means? Now, when we talk about weight, it means that we are actually, okay, let me show you this. If you guys don't know, let me show you this. It's actually quite important for me to tell you this because a lot of people, they don't really know how does this function actually works. All right, draw the rough foundation first, square it up. Assuming I break this into two parts. Okay, for this part, I'm going to create two steel fabric. So show you first one first. Second one. Okay, both of this is bottom bar. Doesn't matter whether it's bottom or what. So let me tell you what's the difference between these two is that, okay, if I use this steel fabric, first one is fabric area. Second one, if I use by weight, let me show you. If I change this by weight, there are going to be slight difference over here. Okay, how does this area gets defined is by, now notice that there is gross rate over here, 319.171, right? And then here also you got 319.171. But what will happen is that you notice that the fabric area is slightly different, right? People ask this question, how come I do this, it looks slightly different one, huh? The reason why is because on the left hand side, if you're using fabric area, the area that you capture over here, let's say for example, if this one is 24 meters square, it will be exactly 24 meters square, right? It has nothing to do with whether there is reinforcement inside or not, whether the reinforcement inside there is slab or anything or not. But if we are dealing with the other method, which is by weight, just now over here, this one, we are going to get 23.6442. We're going to get 23.642. The reason why this is different is because the amount is derived by the weight. So if we take a calculator, which means that this weight means nothing to this fabric area. Let me just remove all the bands. I put all the bands to 0 so you can see the exact figure. Okay, this one is after I remove the band already. You can see that it's 22.213, 22.688. So this is the thing, right? Now, notice what happens when I take a, let me see, what can I measure with? I want to measure with custom area. So I'm going to put two. One is by weight. The other one is by area. the laid area, the one is what I was talking about. Okay, now I calculate everything. Oops, I think this one. You have to be very accurate because we are trying to check the differences. Okay, so I think this one should be correct already. Okay, you can see by area it's 22.739. So I think it's actually the same one, just that it runs away by a bit because I didn't accurately point it just now. So it's 22.739. So go back again to your slab main bar. View quantity is 2. Rough main bar, not slab, sorry. My bad. Okay, then you can see that it's 22.213. So this one is actually tallying with the fabric area just now that we saw. So that's the thing, because we are capturing exact as per what we drag over here. So this is 22.213. But for this 22.688, the reason why it is different is because it is actually derived from this 306.281. So if you look at B13, if we can actually go to project settings, then you go to weight specific setting. Then you look at B13, okay, B13, the weight is 13.5. So just take 13.5. Calculator, you take 306.281 divided by 13.5 is actually 22.688. So you guys can understand what's going on here, the differences between by weight and then by area. By area is because if you look at on plan, you exactly capture the area over there. It has nothing to do with the weight. But if you are using by weight, it will automatically refer to the weight of the total weight of your reinforcement over there, and then convert it back to meter square. So this is the two method. The correct method to do it is to use fabric area, the area by area instead of by weight. So you guys understand what's going on? Up to this stage, can everybody tell the difference between by weight and by area? Yes, so okay, this is very conceptual. If you cannot remember, don't know how to do it, don't understand why, you can refer back to this recording. This recording will be sent to everybody, right? So don't worry about this. It's a recording that we will send to everybody. Okay, now that's all for steel fabric BRC, things that you may need to know, right? So you can refer to the slides I've also written over here. By calculating fabric area will be area on plan that we exactly captured, nothing to do with the reinforcement. But by calculating area from weight, the area is captured by taking the weight of BRC divided by the kg per meter square. So you can get the exact figure over here. So that's the situation. Okay. This one is for steel fabric BRC. So that's all for chapter 5. We are going into chapter 6, ground beams. So for ground beams, actually it's not difficult. It's actually quite easy. I would say that because things that we have learned from, if you have been to my site labor class, everything that we teach over there is exactly the same as ground beams. So I'm not going to repeat most of ground beams item. Only certain items that is different, right? 80% of ground beams and things are the same as floor beams. Those that are not the same one, I will explain to you. those are the same one. I will skip that. And if you want to learn about that, you can go through our site label training. The site label training is really comprehensive. Right? Let me show you a sneak peek of how it looks like. It's super comprehensive. Everything is very detailed. So you really learn how to fill in the information over here. Literally all the settings for beam is taught inside here. So a lot of things also, that's why I didn't want to explain for beam is because of this. All the settings, all the information inside general notes, what we need to key in is inside here. Everything is explained inside site label. So next time you all can try to attend the site label training, then we will teach you how to use the software, how to draw exactly all the information, how to relate calculation rules, and how to actually do in a real project. Right? We explain everything like super detailed. And so for beams, you can really go back there and learn. It's very comprehensive. So this is just a sneak peek. And of course, if can, we actually recorded an online version of this. You can have a look at it next time. Once we release it inside the, what do you call it, our online training platform. Right? So back to ground beams. So you can see that ground beams and frame beams, the setting is 80% the same. Right? Maybe the placing of the thing is a bit different only, right? But it's 80% the same. I would say that if you know how to see ground frame beams, ground beams also you know how to see. Right? You can see that the settings here are almost the same, except that they add certain things. For example, like at the bottom here, you have secondary ground beam, and then after that, inside ground beam, you also have certain settings inside here where you need to change. So talk about ground beams anchorage settings. So this is the one that I want to talk about, mostly about the anchorage settings. Very easy, not too hard. Well, when we talk about ground beams anchorage settings, this is one thing that we don't have inside frame beams, which means overhang. So overhang is, I would say, let's call it cantilever, although it's not suspended, but let's just call it cantilever so it's easier for you to understand. When it is cantilever or there is no support over there, it will actually apply this overhang situation, right? Which means that you will have reinforcement bars that actually hangs out from here and then bend down by 12 times diameter. Same goes to the bottom part here and then bend upwards 12 times diameter. Right? So this is the situation. Then after that we have the secondary one. The primary reinforcement will go all the way towards the end of the second hand. Then for the secondary reinforcement from the top, it will actually stop at the support. It will stop at these two support, right? It will stop here. That's why you can see the reinforcement goes here, and then it goes down, bend downwards by 12 diameter. So this is called overhang. Now, when there is no overhang, it's very easy. The reinforcement will just straight away in at the edge over here. Like normal. I think this one is actually very straightforward. If I explain to you also, if you're totally new to the software, then I may need to re-explain a few times. But if you are an intermediate user, I think usually when I talk like this, you should be able to understand already, right? But if you can't understand, you just let me know, right? Because I'm not too sure how many of you are new hands, but I know most of you here are actually quite old user. A few of you are quite old user over here, but don't worry. If you don't understand, just feel free to let me know. I try to explain my best. I try to explain as much as I can, right? Okay. So this is for overhang, a situation where your ground beams that protrude out over support. I usually call it cantilever, but it is not suspended, it's not hanging or anything, so it's not fit to be called as a cantilever, but the concept is the same, overhang, right? And then we have sidebars. If you have a sidebars in between the beams, the ground beams, you can actually do your settings over here, right? You can change. If you want it to bend upwards, you can put a certain figure, for example. If you want it to bend like 200 mm, you just put 200 mm. If you want it to anchor in like all the way towards the end of your support, then you should put HC minus 1 BHC lah. or in this case, it's actually up to the center of the support, right? So this one is actually quite straightforward also, nothing too much. And then the third one is ground beams anchorage settings. Now this anchorage settings is special also lah, slightly different. So, okay, the situation is like this. If your beams have drops from the top drop down, these settings will be applied. But if you have beams that drop from the sorry, this one is from bottom to top. Sorry, top to bottom, and then this one is from beneath dropping down also. You can see the situation over here lah. When it's going down like that, then it's applying this drop on top. When it's going down from this side, that is applying drop on bottom. So you just need to understand this concept. It's same like variable section, just that we have multiple layers over here lah. This one is the first primary layer. This one is the secondary layer. So all these layers can be changed inside site label, right? So if you enter the site label training, you should be able to adjust all those information, right? Okay. And then we have two different ones because this one is for drops that has support. This is for drops that has support over here. And this one is for drops that does not have any support. No support over here. So make sure that you understand the situation. Over here lah, ground beams. This one is basically the same as the variable section that I showed you earlier on just now from slab. Same concept, just that this is for beam. So for chapter 6, ground beams, any questions so far? I think should be not much question because the site label part or the common part of the reinforcement is not part of the syllabus, is inside site label. I think the questions should pose more to site label than site. So, but anyways, any questions for ground beam so far? Anyone's having issues? Anyone having hard time trying to understand this particular topic? No. Okay, quite straightforward, right? So towards the back, chapter 6, 7, 8 is all very straightforward. What about others? Can understand? If you require me to give a recap, just let me know. I can do a recap for you. Okay, I'm going to assume that everyone does not. We're going to talk about brick walls, right? Brick walls. So, masonry structure, the first thing that comes into my mind is always stiffener, right? So I think this one, last time also I've shown before how to do auto lay your stiffener, right? So I'm not going to show that one is part of intermediate training. But here I want to talk about is the calculation rules. So how does this calculation rules actually affect the quantity that you have from your stiffener, right? So as you can see over here, masonry structure, we have stiffener settings. Specifically, when we talk about stiffener settings, there is also Anchorage for stiffener one. For example, you anchor into your slab. How does it look like? Or when you anchor your, what do you call it? When you anchor this stiffener into the bottom part of the RC foundation, how is it anchored? Or bottom on a non-RC structure element, for example, maybe, I don't know, do we actually put reinforcement on something that's non-RC? I don't think so, right? No, we don't do that too often. So this bottom not on concrete one is actually very, very rare. We don't really do that. Then we also have something that is actually quite familiar to your eyes, section change. And then section change with join, right? So this is the kind of things that you need to understand. And then we also have filler walls. Just to let you know, filler wall is actually brick wall. They just call it filler wall. It's brick wall. So in TRB, you can actually apply reinforcements into your brick wall. So you can actually have reinforcements plunging up from your brick wall down to your slab or whatsoever, right? You can actually do that, but we don't usually do that. It's because our brick wall is usually supported by stiffener instead of the brick wall itself, right? So that's the situation. Now, let us go through how to play with all this information. Stiffener settings. Let's go into stiffener. Again, same as always, delete everything that I don't need. Okay. Let's see, stiffener. Let me put the slab first. I put a stiffener over here in center. Oh, we already have a stiffener there. Okay, so this is my stiffener. So the default settings over here, you can see anchoring to the top part, LA. Instead of LA, let me make it more easier. Let's change this to, okay, let's just change this LA to 1000, right? Easier to see. And then after that, bottom concrete, this one also I changed 1000, so that it's easier for us, right? So I changed this to, when I calculate, one thing about stiffener, the bad thing about stiffener is that you can't see the reinforcement in 3D. So you can only see in, what do you call that? You can only see inside this edit rebar over here, right? So you can only do it inside there. So when we talk about stiffener inside Masonry Wall, okay, yeah, let me see. RC foundation. This one I need to change to rough element conversion. Oops. Forget to explain to you. Just now, this one we need to change something first. Hold on. Okay, for a stiffener, if you want to adjust, I think this is not inside the slides. Okay, for stiffener, if you really need to adjust the bending part, is actually inside here. Right. So this one is in order for you to get this bending point, you need to change the embedded parts to top and bottom. Otherwise, it would be actually using planting bars. So when you put in planting bars, it will be following this anchoring depth. So we don't use planting bars. If you want it to bend inside inwards the reinforcement up there, then you need to use embedded parts at both top and bottom. Otherwise, you can just use, for example, there is a few for you to choose, right? You got obligated bar at the bottom, embedded part at top, obligate bar at bottom, planting bars at top, obligate bar at top and bottom, embedded parts at both top and bottom. Embedded parts is where there is a bend you can actually use, right? For planting bars, it's going to be straight. It is going to apply this straight. So this function over here will not be working if you are not using this planting bars. If you don't change this planting bar to embedded parts, both top and bottom, and then that won't work, right? So this is for stiffener, that's the situation. Now, how about when you talk about when you want to use stiffener, right? So you will have a situation. Okay, let me show you Masonry Wall. Let me draw some walls over here first. So you can see masonry wall here. This one is frame filler wall, which is your brick wall also, right? So this is brick wall. So in our brick wall, we can also put this reinforcement inside. So if you put reinforcement inside, it's going to have this reinforcement, which is not what you would want, right? Because most of the time, your reinforcement, you won't have this. Unless otherwise, inside your drawing, you have two, right? It says that you have two 2T, for example, 10. Oops. 2T10. 100 lah, so you can have two, right? So assuming you have this masonry wall, the reinforcement. So what it does is that you will have this reinforcement and the bar will go like this. It will go straight like this. Right, so the rebar will become like this. Depends on the situation. We don't want to put this as the filler wall part. Because why? Not all reinforcement, not all will be all the way up, right? You can see over here, it goes all the way up, this tie bar goes all the way up, which is not what we want. If we take 28 quantities like that, then it's wrong already, right? We don't want this to happen. So just to let you know that you can actually use this up, but I wouldn't recommend you to use masonry wall to put the reinforcement inside. It would be wrong, right? So you can see 5730. So this one is the length, the total length. Like we don't want this to happen. So again, like always make sure that in cases like this, if you really want to do this, you may need to change this quantity over here, put it to 2, and then you need to lock the wall. You need to lock the wall. So this is an alternative way to do it, but I don't recommend you to do this. You only do it unless you have no choice, right? You have no choice, then only you use this method. Otherwise, don't do this. Or you can use this wall segment method. Don't need to use wall segment. Don't need to use wall segment method. We're not going to use this anyway. This is just to let you know you can put reinforcement inside masonry wall, right? And the masonry wall, why I don't want you to use it is because the reinforcement will go from bottom until the top, which is going to be wrong. Here, 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 until 28 piece all the way up, which is wrong. We don't want it because usually this type of wall, the reinforcement will be at the bottom. For those kind of general notes that I've seen before, it's always at the bottom one. And I only see 2 at the bottom part. You have 2 horizontal bars at the bottom part. The top part usually won't have reinforcements even. Right? So that one is for the filler wall. So you can see that process of stiffener, when you have a stiffener inside the filler wall, and this is when you use the embedded function that I showed you just now, which is this one. Embedded function, if you put 1000, there's going to be 1000 bending length for both top and bottom. See? So we need to be a bit careful when we try to adjust. When we adjust this information, we have to be very careful of the bending point, right? So you will have dowel bar also. This is going to be the dowel bar, the bottom part here. And at the same time also, if you scroll to the bottom, here we have section change part. If you have different kind of size for your stiffener, you can actually use this section change or section change with join. This is actually the same as the column that I've shown you just now. If you are using column, this is the situation, right? Okay, let me see what happens if I take this out. Foundation. Put a tile cap there. I'm not sure why this tool is not applying. I have to check into. By right, if I change this top and the bottom here, it should actually follow. Let me try and see. This is not supposed to happen. Correct? Not sure why is it. In the previous C2 version, this can work. C3 version, I don't know why we have to follow this one. This is so strange. I don't think it's the Anchorage length value issue. The thing is, this is not applying. So for example, if this one is using planting bars at both top and bottom, these settings actually supersedes both of this. So this two setting is useless already after that. No matter what kind of connection I have with other elements, this doesn't take place. So something is wrong with this one. I need to check with my product team. But this one is definitely working. The settings here for the bending length is definitely working. So because it's not already experiment, if you change this to embedded parts to both top and bottom, and then if you change the figures over here, it will actually follow. You can see it actually follows. So that's the situation. Either one of this is actually superseding. Actually, this entire settings over here is superseding the settings at the bottom here. These two. So never mind, we just ignore this one first. We just ignore this one. I need to go back to my product thing and check with that. What's the purpose of this? Yeah, we're just going to use this one, right? So this one is for the bending. We just adjust the bend from here. Process of the stiffener for the filler wall. Right, just use this one. It doesn't matter if it is for RC or RC foundation or any kind of foundation, any kind of element, you can just use this one. Cannot change. There is no particular information here for me to change. Never mind, then we just use this one first for the time being. If you want to change the band or the value of the band, you can just change it inside here. Okay. So let me see. This one I may need to change. Section change with join. Okay, let's have a look at the section change. But usually you won't really have section change one with stiffener because it's so small. It follows the wall size. But who knows? Let us try. Let's try. Let's put 1000. Copy this upstairs. $500. So I'm just gonna remove the slab here because kind of blocked it. Oops, this one. Was wondering what was blocking floor bottom. Okay. Oh, we can't see this 3D lah, so just bear with me. They are still working on the 3D function for this stiffener one. Okay, then you can see but the variable section actually works. The variable section works. However, you see the variable section actually works. There is a variable section over here. It works, but for these two settings, I don't know why. So this one I have to check again in my product team. These two settings, something is wrong already, because it actually by right, to be honest, by right, this one is supposed to be the Anchorage settings for your stiffener one. We cannot be using this one. This one I have to check that. Right, but for the time being, we're just gonna use this. So the section change actually works, right? But for these two, you just try to put this aside first. Try to put this aside first. We are gonna use this item here, right? So that's all for stiffener. Nothing too much on the settings. So any questions for stiffener? I think stiffener also nothing too fancy. But if you ask me, sometimes when I use stiffener, I tend to change it. I will convert it to column one. I will usually convert it to column. I usually convert it to column because it's much easier to use. So if you change this to column already, it's still going to be, you can label it stiffener also, right? Once you change this already, you just label it as stiffener lah. Then it will also act as the same. But the settings that you have, you can use column settings. For example, like calculation rules here, you just go to column settings. And whatever you do for those stiffener that I changed, converted to column just now, can be adjusted inside here as well. So just now, why the concept I was mentioning about was this supposed to be these few items, right? They are supposed to follow this for the masonry structure. But unfortunately, these two were not able to work, which later I have to confirm my product team the purpose of having them there. Okay, so this one, never mind, we just leave it be first. Right, so this for masonry structure, stiffener settings. Any question for stiffener so far? Any questions? No. I think stiffener also quite straightforward. If nothing, then I proceed to the next item, yeah, which is ring beam. Ring beam we don't really use one, so I'm just going to bring you through. So usually when we talk about ring beam, it's similar to other beam function, but the time when we use ring beam is when we are dealing with, you can say, high beam, right? Have you heard of this type of situation where you have, okay, let me show you. You have walls, you have masonry structure walls. So this wall is very tall, about 6 meters like that. So usually when it's so tall, until up to 6 meters like that, what's going to happen is that, +6. What's going to happen is that you will usually have a tie beam in between. So the ring beam purpose is for you to do that. But usually, if you ask me, I won't use ring beam. I directly use beam to draw. It's even better. Right, you can use ring beam to draw. So that's the purpose of having the ring beam. But if you ask me again, I wouldn't use ring beam. I directly just place it under beam so that everything is more synchronized from the high beam. And I don't need to change so many settings. Then you can use this function, wall center line, just select on this wall, right click, and then you can find your beams here. Or you can put at the center also if you want. Floor bottom plus 3. Again, wall center line, just point it here, right click. Then you have your beam over there. So this is my tie beam. So usually that's what I do. If I have tie beam and I won't use ring beam. Honestly speaking, if you ask me, ring beam is a function that nobody uses. Nobody will use ring beam. It doesn't work that well compared to normal beams because beam is a much more complete function. If you use ring beam, the thing about using ring beam is this. Let me show you. If I draw, and I calculate it, I cannot see rebar 3D. That is the problem. I can't see rebar 3D, so nobody wants to use ring beam. This is one of the purpose. One of the reasons why ring beam is not a popular function to be used. So pretty straightforward lah. If you want to use for tie beam, just straight away use beam. It's much better. Right, so for ring beams is easy. L corner, T corner, and then after that end of beam. So the settings over here is very general. Right, same like normal beam also, but then like I mentioned, there are some limitations. You can't view 3D. It's difficult for you to identify which location is the reinforcement. So I don't recommend to use ring beam, just to show you that we have this function. And then the last one is lintel settings. So for lintel settings, it's also using planting bars. You can adjust what kind of planting bars you want to use, the connection type. So when you go into the settings here, you go to bottom part, the lintel part, you can see that there are a few types of settings, right? You have planting bars, you got obligate bars, and then we also have embedded bars. So if you use obligate bars, your settings or your Anchorage settings will be 30 diameter. If you use planting bars, your Anchorage settings will be 10 times diameter. If you use embedded bars, your settings will be 10 times diameter. Right? So this is just to let you know which one you want to use. This is on situations where you have different kind of lintel, different size of lintel. Because lintel is always separated by size, but like less than 2 meter, more than 2 meter, but not exceeding 3 meters. So there are a lot of lintel that have different kind of settings. So in cases like this, you can choose which kind of planting bars you want to use, right? So that's basically just it for lintel, nothing too much also. I think for this chapter also quite straightforward, right? Any questions for chapter 7? If there is question, you can just ask. If no question, you just put a note so that I can proceed. Any questions? No? Okay. Actually, chapter 7 and chapter 8 is things that we rarely use. Rarely use, but I still need to teach because it's part of the software. If you ask me, I always use back same element one. I only use beam, pile cap, rough foundation, slab, column. Stiffener, yes, I do use stiffener, but not too often. Depends on the situation. Sometimes I use stiffener already. I generate all the stiffener already, then I convert everything into column because I prefer to have column settings compared to stiffener settings. Stiffener settings is quite limited, like what you saw just now, just a few items. But if you use column settings, you can do much more with the stiffener. So depends on how you want to play with the software. There is no right, there's no wrong. Depends on how you like to use it. Okay, so if there is no much question, I'm going to move on to the last chapter, which is chapter 8, others. Now, inside others is just mainly about curve. Curve is a function that we rarely, not to say rarely, we do use, but if you ask me, like I mentioned, I like to use alternative things. Curve is something similar to beam element also, just that it is protruding out from slab and things like that. So for curb, you can change certain settings. It also uses planting bars, right? It uses planting bars, so at the corners, at the edge of the curb, what it does is that it will anchor by using planting bars, embedded parts, or obligate bars. Depends on which one that you are using, right? So like for cases curb, let's say if you decide to use curb, right? If you decide to use curb, you want to use planting bars. So default is already planting bars. You just need to adjust the anchorage value over here. All right. Then after that, for other curb settings, I would say you can adjust the anchorage at the bottom and on the top, even though if you have a curb with nosing also, right? So, but curb, the thing about curb is that you can only draw it like this. In order for you to have these nosing settings, you need to use a beam to substitute it. You need to have a beam to substitute it. Then only you have this nosing. That's why I say, if you ask me, I prefer to use beam to draw. I don't like to use curve to draw curve. Because if you use curve to draw curve, if it's simple design, then okay, it's fine. It's good to use. I can't see 3D, but the function is there. It's good to use. But if it is a very complicated or very tough curve, I usually won't use curve to draw. I will use beam to draw my curve. Or you can use RC wall to draw curve also. So there's a lot of alternative. Same goes to elements such as plane. You know, let me show you. When you do those water tank plane, right, it's always protruding out. So plane, with RC plane. So this type of plane at the bottom here, this type of plane, what I usually do with the plane is I would usually use either beam or RC wall to draw, depending on the design. If the design is more towards beam type of design, then I will use beam to draw. But if it is more towards RC wall design, then I will use RC wall to draw. Depends on the situation, right? So this is when you need to use alternative to substitute. I always use alternative one. If you ask Kin, hey Kin, what do you use to draw? What do you call that? This type of plane. And honestly speaking, first thing that comes in my mind is beam, because it has the shape of the beam, characteristics of a beam. So you can choose to use beam to draw this also. And when you import into TAS, you can also point your finishes over the beam. That's what makes it nice to use, right? Just to let you know that you can actually do that. So for curve, we have a few types. Curve bottom, we have curve top and nose. The nose you have to use beam to draw, right? Then we have curve corner, curve T-joint, and curve end. So of course we will show you if it's written plan view means you are viewing from the top. If it is not plan view means it's actually elevation. This first three is elevation view, right? The last three is plan view. So the settings is generally the same. If you have a curve that is actually touching a slab or a beam below, it will actually anchor it, and then you can just put the LA here, right? Same goes to the curve top. If there is nothing at the top here, there is no connection between another beam like this type of nosing, then you will apply this type of finishing. I mean, you will apply this type of reinforcement placing. Same goes to your curve top and nose. If you have a beam, if you have drawn a beam that looks like this, something like this, oops. If you have drawn a beam like this to act as a nose, then this formula will take place. For curve corner, it means that when you have a curve that bends like that, you will actually apply this. Let me show you on the software. Curve. I rarely use curve. I always use beam to draw curve. More practical. Okay, see I have curve over here. So I just calculate. And then you can see that this 90 is the bend. Sorry, the 96 over here is the bend horizontal bar of curve number 2. And why I don't like to use curve is because, again, I cannot view in 3D. So sometimes it's very hard for me to imagine. I really need to know which reinforcement is from which reinforcement. So I have to look closely. That's why I don't like to use this. If you want to use a good one, then straight away use beam. If you want to view 3D, straight away use beam. Don't need to think already. Curve is just an additional function that I think certain situation you will use, but other than that, you will use it, right? So I think that's just about that. Nothing too much really. This is the nosing that I want to show you. And I guess today's training is just up to that. Oh, just not the file that I sent to you. Don't know, have you guys received the file? Have you guys received this? What do you call that? The calculation rules tryout. You can have a look at that. I put everything side by side so that you can see those information over there. The PDF file that I just sent to you inside the chat box earlier on. Can you guys see that? This one. You can actually take a look at this. I think this is actually going to help you a lot. Right, we got standard stiffener details. Then we have wall intersection. Teach you how to apply all this information. And you can look at the lab splice. This is how I key in the information. Right, you can refer to this. Okay, up to now, does anyone have any questions so far? That's all only for today's training. So if you want to apply for your certificate, you can scan on this QR code over here. You can apply for your intermediate certificate. And of course, the requirement you can see over here. Later when we pass you the slide, you should be able to see the requirement over here, right? And then after that, now we reach the Q&A session. Okay, one question, how to do for cobble? Cobble actually very easy. Again, we do have a specific function for cobble, right? We do have a specific function for cobble. But if you ask Keen, you can use coping to draw. If you ask Keen don't like to use coping, don't like to use curve, don't like to use eve, don't like to use all this mini function one. The reason why is because we cannot view rebar 3D. So for example, if I draw my coping already, even the reinforcement also I need to put under other rebars, which is very troublesome. I don't like. So if I have reinforcement, usually I toss it under beam. I will toss everything, I'll draw everything under beam. And once, let's say if I have some reinforcement over here already, I calculate I cannot view rebar 3D. There is no way for me to view rebar 3D if you use coping. Use beam, substitute cobble. Use beam to substitute cobble. It will be much better, right? So if you want the recording for today's session, feel free to fill up this feedback form over here, right? Fill up the feedback form, then after that, from there, I'll filter and send out the recording maybe tomorrow morning. I'll send it out tomorrow morning. Any other questions so far? You can ask me anything else, even if it's not related to TRB also, as long as it's related to QB cost, then I'm good. Any other questions? Maybe let me just scan the link now and then send into the chat box there for you all. Got a question, you can feel free to ask me, right? One moment, I'm copying the link inside chat here. Okay, I've sent the feedback inside the chat already, so you can have a look and see. You can fill up the chat over there. Can we set automation as Autodesk Revit? What kind of automation are you talking about? I'm not too sure. Autodesk Revit is a very, okay, the comparison between Revit and TAS, TRB has been made for a very long time. Well, as a user for both Revit and Cubicos product, what I would say is that Revit is a designing software. It's more to designing, you know. Then after that, for TAS and TRB, it's more to quantity taking off. So if you're talking for auto rebar and concrete work, yes, we do have auto. So if you attend our intermediate training time, you should be able to use this. You can go to identify, and there is a lot of function there. For example, main bar, we have identify slab main bar. So if you have slab main bar all written into your layout, you can actually use this function. It will automatically capture everything. Same goes to this one. Let me see. Beam. Yes, beam also same thing. If you have schedule, for example, for site label, you have schedule, you can actually identify the schedule. And then once you identify already, those information will be placed inside this beam schedule. It can be synchronized to all the drawn beams that you have on plan. So I would say, okay, beams you can do auto identify, slab you can do auto identify, column also you can do auto identify. So I would say most of it also you can do auto identify. If you really want to learn how to do auto identify, you can join our intermediate training, the TAS and TRB intermediate training. Both also we do teach. Yes, for quick calculation, pre-tender estimate. Okay, just to check with you, for your PTE, do you use poundage or do you still measure rebar in detail? You can turn on your mic now. You can turn on your mic now. If you want to use voice to talk also can. Okay, you are using reinforcement bar, right? Okay, if you're using reinforcement bar, the software itself have a set of settings inside already which you can use. Let's say if you don't have a particular guideline to follow, you can use the default settings, right? So of course, when you use the default settings already, depends on your company practice. Last time when we were doing our PTE, the time, a lot of things also we did. For example, auto identify reinforcement, right? What I can say is, okay, when you talk about reinforcement, maybe let me show you an example of my project. Which one should I use? This one is a real project that I did from before, so whatever you see here is actually quite legit. Okay, it's a small project, but I show you what do I mean by automated. So when I did my reinforcement, for example, like, do I have beams? No beams. Slab. I actually use the reinforcements auto identify function. Yeah, I don't have the drawing. It's not inside here with me. So you can actually, for example, like this one, you want to quick identify, right? You don't need to draw everything manually one by one. you can just use identify slab rebar, pick rebar line. For example, this one, pick rebar line, right click, pick rebar label, right click. Then after that, if you have range, then you pick range. If you don't have, you just auto identify. But this one don't have range. I don't have the actual drawings. So I can't show. Let me see if I have other project that I can show. I'm not sure if this one have it or not. Maybe I can show you the auto identify video that I had. Excuse me. Let me workshop. Okay, I can show you this one. This one is actually old slides that I used to teach, right? So basically, we got a few types. Foundation, you can auto identify. Column, you can auto identify. Shear wall, you can auto identify. Beams and slab, you can auto identify. Then after that, either way, slabs and beams or slab also you can auto identify. So inside here, okay, there's videos inside here. I can show you. Let me see. For example, like column schedule. For example, this is the column schedule. You can actually auto identify. So these are the details. Instead of we do everything one by one, right? You can actually do this. I can't find this video already, so I have to go through this slide. sorry. So you can actually capture everything like this. Saves a lot of time. Okay, once you capture everything ready, identify everything, you just need to drag identify. For your stump to level 1, let's say for example, I'm doing stump at level 1. So everything okay ready, just press OK, and then it will generate all this column information for you. Right, so you can see each and every one of the information has already been keyed out like that. So this one is for column. We got a few more. Column on layout also you can do it. Right, you can identify the column and layout, pick side line, pick label, and then auto identify everything. Right, so all the reinforcement will be automatic. So after that, you just need to synchronize everything together only. You can have all the reinforcement, everything automated. Let me see which one. Okay, slab also same thing. You can see that. Auto identify. You don't need to do everything manually one by one. So when you auto identify, the software will automatically draw all the slab things. So all the slab entity will be automatically drawn if you use auto identify. And then after that, we have the next one is laying VRC, also same thing. Automatic, based on drawing. You can see auto reinforcing, then you can key in all this information like that. So this one is part of another training inside calculation rules. We don't have this. Calculation rule is just solely teach you how to adjust calculation to get the correct data for your project's reinforcement. You can see all the reinforcement automatically laid for you. So this is one way. And then we also have slab main bar also. Let's say if you are identifying main bar also can. Right, same thing. Big side label, big bar range, things like that. So the software will automatically read everything for you and then you just press auto identify. Then all the reinforcement will be automatically laid for you. For wall also same thing. For wall also same thing. We have a function also, which is identify. So for me to show you everything, it's actually going to take a long time because all of these also can use identify and then everything can be automated. So I don't think I can show you everything. It is quite long. I think you get the point, right? Everything can use auto identify as long as you have CAD drawings. You have the CAD drawings, then you can do the auto identification. If you don't have CAD drawings, then you will be able to do that. Is that okay? If you guys have any questions, feel free to open the mic. The floor is yours now. The floor is yours now. I will try my best to answer everything if I can on the spot. Any questions so far? Yes. Quick calculation is essential for QS to make cost plan. So previously, last time back then when I was in RLB, we also used the software to do this quick calculation. So if you're talking about cost plan, we measure everything pretty fast with the software, especially when we use the auto identify. It is essential. We understand the situation where it's essential. We did have I mean, back then when I was working with consultant at the time, we did have a system for us to do when it comes to this type of cost plan. Any other questions so far? If there is no other questions, I think we can end the session already. Thank you so much, everyone, for your support and your help to join today's training. This training will be conducted in online. I mean, we're going to make an online training video. Next time you all can refer back to the training video. It'll be much easier and better for you all. Especially when you're during working hours, you can't participate in this kind of training, right? So we are doing this online training platform. I've already recorded the videos and everything. Next time you can directly refer to the training video, especially for site label that we have calculation rules, we have intermediate TRB, intermediate TAS, all this kind of information, right? So don't worry if you can't catch up today because the video recording will be sent to you. And at the same time, don't worry because this training is going to be made online also next time. Online as in recorded, so you can watch as and when you like, or when you're free, or when you're doing a project and you don't know how to do that particular portion, you can view the video. Right, I hope today's session was able to help clarify certain doubts from your side there. And if you have any further questions that you think that you may need to, you have some further any kind of questions that you think that you may need my help, you can actually contact me through my phone number here. You can call me Kit. So if you have any questions regarding your project or anything that you need my help, you can just let me know. I will try to reply if I'm able to, right? So thank you everybody for attending today's class. It's been a pleasure for me to teach everyone here today. So stay safe everyone, drink plenty of water. Bye-bye. You're most welcome. See you guys, everyone. Bye-bye.